8.5. Let me look at these in a second. 8.5, I'm going to have to graph, even though I usually tell you guys not to graph. I would rather not graph. With the vectors, I had to graph some of it simply so you could see it. Now, normally in class 1 through 12, I would do them all and we would talk about them. The biggest deal is for vectors to be equivalent, they need to have the same magnitude, which is the same length, and be tilted the same way, which is the slope. You guys have already done slope since algebra. You've already done distance, same distance formula since algebra. Most of them you can look at and see. They do not have to be in the same place. They just have to be equal in distance and slope. And I did write down the distance formula and the slope formula, which should give you an algebra flashback. Okay, the rest of 8.5 was the vector addition. I prefer the parallelogram method because it's the easiest one to talk to you guys through. I will tell you that after I've done them for a little while and reminded myself, I prefer the head to tail setup, but it really doesn't matter what setup you prefer. There are tons of vector addition websites, and you can do vector addition on your calculator if you figure it out. It is a physics and engineering thing. It's also a game design thing if you're not already using somebody else's format or, what do they call that? Somebody else's platform. There you go. But anyway, to do the parallelogram method, you just pick a horizontal line. One of the vectors goes on the horizontal line. The other one, the end, sits exactly where the end of the first one is and goes either up or at an angle or whatever angle it goes at. And then you reproduce them to make a parallelogram or a funny square. And the diagonal of that is the answer of the addition. Now, the reason we do it this way and the reason it's in this section of the book is because the math and the mechanics and the technique that you need to do that are all the stuff that we have just done. They are the law of sines, the law of cosines, trig formula, all the triangle setups. That is how you do it. I have done several of them with steps. As the further I got, the more I skip steps, which is the way I've done all this stuff. You need to do inverse sine. You need to do inverse cosine occasionally. You end up with magnitude and direction. It took me about a page a problem. I'll do the same thing on the test I've done on the others. Pretty much you'll have to reproduce one or two of these on the test. I did not do them all because we are not in class and it takes forever to write these notes up. But I did a nice selection and that's what I'll ask you to reproduce.